Okay, so here we have problem 6 on test number 2C. Topology here is a little tricky, but if we go back to our fundamentals, we can solve this without a problem. So the first step during node voltage is to find all of the nodes. And nodes are where current branches 3 or more times. So looking at the circuit, I see one node here, I see one node here, and I see one node here. I can discount ground because V ground just equals 0. And since we're solving for voltages, I don't really need to use that. We can do a KCL here at this point, but it would just be an extra equation we don't really need because we've got 4 nodes. All we need is 4 equations. If we use Vg equals 0, that's one equation. Next, I go over here, V1, okay, V2, V3. Starting at V1, I see I've got a voltage source in between this point and the other point, V ground. But since V ground is 0, I can just write my equation as V1 equals Vx. We'll see if Vg was a positive or non-zero number rather, that, well, that doesn't help us a whole lot. We need to use a supernode. But since Vg is 0, this cancels out. We just get V1 equals Vx, our first equation. Next, we go to V2. Again, here we have a voltage source in between V2 and V3. So if I follow the same format, now I realize I need a supernode. And we can just connect our supernode by scrubbing out our lines here. I'm not replacing any of these nodes. I'm just going to draw a bigger circle. One thing to note here, resistor R3 does not get included in that. And we'll see why later and how that affects our supernode. So we've got 2 equations, technically 3 if we count Vg equals 0. So let's do our supernode to get our 4th equation and finally solve this. So first we've got some kind of easy ones. We can see a current leaving here, current leaving there, and then 2 more currents leaving up there. So I'm going to start with the easy ones. V2 minus V1 over R1 plus V2 minus V1 over R2 plus V3 now over R5 plus V3 over R6. Now, we also have this independent current source. We want our node current, or the branch current, to come out like that, but that's in the opposite direction, so we just subtract it. Now for R3. Well, we know that there's a current coming out here. Okay. V3 minus V2 over R3. But there's also a current coming out over here. V2 minus V3 over R3. Now you can see these are just equal and opposite, which means those are 0. If you include them in your equation, that's fine. Those are 2 branch currents that we need to know. Otherwise, it doesn't really matter. And we can just write our 3rd equation like that with those 5 terms. So let's recap. We first identify our nodes. The nodes are places where 3 or more currents branch. It's not a point, but it's a segments of these wires. And if you look in the old tests, a lot of them ask you to identify where the nodes are, and those are colored in. Check those out. You can see what I mean here, why this whole area is our node. Okay, so step 1, identify nodes. Step 2, we find all the branch currents leaving those points. So I go around my square, say here at V1. So I go up, I get to a wire that's crossing it. bam, current. Go over, bam, current. Line crosses, okay, another current here. I realize that I have no idea what this current is because of this voltage source. I resort to just saying V1 equals Vx. Gives me my first equation. Second, okay, I see now I've got at V2 and V3 a supernode. One of those equations I can just relate one to the other. V2 equals V3 plus Vy, or V3 equals V2 minus Vy. Both are valid. Then I draw my big supernode, and I use the same process as I did at V1. I go around and I find where wires cross. So I've got the one here, then I go all the way around, and I finally get over here, and I find the current over R6. All the way over here, R5, find the current on that branch, come up. Okay, now I've got one at R3, go around. Now I've got another one over R3. Come here, I come to the independent source. Finally, over to here at R2, I find this current on that branch. And I get back to where I started, between R2 and R1, and I don't find any more currents. So there I'm done. That's my complete circuit around that node.